Hi there, this is Thiru, author of BITBEE. Welcome back to the channel and the LeetCode 150 series. Today we are into the problem number 6 and the problem is three-sum problem. So the problem statement is, we have given array of integers. We have to return all the triplets such that num of I plus num of j, num of k is equal to 0, where I and j, k are any indexes in the array. Okay. So in a given array, there is a possibility of one or more than triplets whose sum is equal to 0. There is also a condition given that solution set should not contain duplicate triplets. We should have the solution all the unique triplets only. So here is the actual LeetCode problem given. This is the same problem statement what we discussed just before. So now we can just go through the examples. In the example 1, there is an integer array having -1, 0, 1, 2, -1 and 4. If you see the output of the first example, there are 2 unique triplets are possible, right? But there are total 3 triplets. Out of that, there are only 2 unique triplets possible. Just let me draw all the triplets once here so that you can see them clearly. The triplet 1 is -1, 0 and 1 whose sum is equal to 0. Then triplet 2 is 0, 1 and -1. Similarly, the triplet 3 is -1, 2 and -1 whose sum again is equal to 0, right? 0, 1 and -1 are duplicate triplets. We can ignore 1. Second example, array given has only 3 elements 0, 1 and 1, so there is no triplet possible. And in the third or the final example, the array has all zeros, so only one triplet possible, that is 0, 0 and 0, right? So let's start with the brute force solution first. So as a part of brute force approach, we can take the help of loops, right? Here we can put 3 loops and we can iterate through all possible triplets, right? And we will check for the sum of the triplets at each iteration. Whenever we find a triplet sum is 0, we can push that triplet into a set. The reason we use a set to store the triplets because it will make sure there were no duplicate triplets in the set, right? So this is the simple brute force approach to solve the three-sum problem. Let's quickly check one example through dry run so that you will be clear with this. So let's take the same array that's given in the LeetCode first example. So when we dry run, initially the I is 0, j is 1, then k is 2, right? So the first triplet will be -1, 0 and 1 whose sum is 0. So the unique triplet will be -1, 0 and 1. In the next iteration, I is 0, j is 1, k is 3. Here the sum is 1, so it's not a required triplet, right? We can ignore. In the next iteration, the sum is -1 plus 0 plus -1 is -2. Again, this is not a fit one. I hope now we are on a point. So when we go through all these iterations, we will ignore which are not matching to the sum, right? So when we reach the end of the iteration, we will totally find 2 triplets only, right? Yeah, so that is all. Three-sum problem, brute force approach. Just use the loops. Here the 3 loops and take the help of a set and you got the solution. Okay. Now let's code it quickly in Python. I hope you are in a position to do that. Here I define a simple method, three-sum brute force, which will takes the input array as parameter, right? Then I have taken or declare a empty set, which will store the triplets or unique triplets. Then as usual, we have started 3 nested loops. Each will start from 0, 1, 2 respectively. And inside the nested loop, we are calculating the sum of the 3 numbers, right? If that is equal to 0, we are taking the help of tuple and we are putting that into the triplet. Again, we are adding the triplet to the set so that it will make sure there were no duplicates, right? So similarly, we can also quickly write this code snippet in Java. Here we do. So even in Java, the code looks same, only the difference is syntax. And here also we are using set, right? Internally it is taking set, which has capability to store the unique elements or unique triplets here. Then of course we are putting each triplet in a list and we are storing that list in the set or unique triplet, right? That's it. So now let's run this brute force solution in LeetCode to check its performance and its complexity. Here I'm typing the same code in Java. So it's almost done. Let's click on run. Here we go. It accepted all the test cases, but when we try to submit, looks like it's taking some time. Here we go. It's given time limit exceeded, right? Now, let's think about some better approach or some more optimized solution. If you remember, in two-sum problem, we have used some technique called two-pointer technique, right? I hope you are able to recall it. In this two-pointer technique, usually we will sort the given input array first, okay? Then we'll take the first element and we'll fix it, and we have to find out a complement, that is sum minus our fixed element, that is 0 minus our fixed element, right? Suppose here in the example, our fixed first element is minus 2, then we need to find the complement 0 minus minus 2, that is 2, right? And this complement 2, we will take help of two pointers. The first pointer points to the second element, and the another pointer points to the last element. At any time in the iteration, these sums should give us 2. I hope you are on the point. If you are not understanding this two pointer, you can go to our very first problem, that is two sum problem. There we followed this two pointer approach, okay? So nothing to get confused much. At any point, we are getting the required complement using the pointers. So let's jump into the coding part for this two pointer approach. So I'm quickly showing you here the Python code snippet for this two pointer technique. Don't worry about the code. This code is available in our Bitbucket repo. You can refer it anytime. So here we have taken two loops. The outer loop is a for loop to iterate through all the elements, and then the while loop, okay, where we will iterate between the two pointers, that is first pointer and the second pointer. Here I have taken the pointers as left and right, okay? So at any time our target will be target minus nums of I, right? We have to find the complement. So if our current sum is equal to our complement or the target, then we found the triplet and we are adding the triplets to our list, right? Once we find the triplet, as usual, we are increasing the pointers left and right. Here actually we have to increase the left pointer towards right, and we have to decrease the right pointer towards left, that is right minus 1. Anytime if our subsequent elements, that is left and left minus 1, are same, we have to skip that elements, right? And finally at the end of the while loop, again we have to move our pointers left and right. That is what we are doing. Left equal to left plus 1 and right equal to right minus 1. So you can go through the entire solution once, that is Python code. Anyhow, this is available in our GitHub repo. If you have any confusion or not understood until what I explained for the two pointer approach, here you can go through this simple dry run example for this approach, okay? So in this example, we have sorted our input array first, right? Then we have taken our fixed element I as 0 in the first iteration. Then left points to the first index, right point to the fifth index. So here the fixed num became minus 4, and the current pair value, that is sum, is minus 1 and plus 2 is equal to 1. So which is not a required complement, right? So it's not a triplet. Likewise, in our second iteration, the fixed num is minus 1, right? And the current pair is minus 1 and 2, they are giving 1. So now the total sum is minus 1 plus 1 is equal to 0. So we have got a triplet, minus 1, and 2, right? Similarly, in the third iteration also we are getting one more triplet, that is minus 1, 0 and 1. There is an elephant in the room. Here you have sorted the given input array, then you have finding the required triplets. Still there is no issue, because here the problem asked only the triplets, not their indexes, right? So there is no issue even if we are sorting the given input array. Finally, to the point, here I am trying to run our Python solution in the LeetCode. I have ran it. It has passed all the test cases, and I try to submit, expecting to accept the solution, and it's accepted with 85% of efficiency. So it is better than our brute force solution, right? For our Java base, I'm showing the same solution in Java. So the logic is same, only the difference is syntax between Python and Java. You can see the for loop, while loop, and the logic with the two pointers inside. Don't worry, this code also available in our GitHub repo. You can go through. The link is available in our comment section. So coming to the final summary of this problem, we have followed two approaches, that is brute force and two pointer. In brute force approach, the time complexity is n to the power of 3, right? We have used 3 loops and the space complexity goes to O of n. And in two pointer technique, our time complexity will reduces to n square, because we have used only 2 loops, for and while, and the space complexity is O of 1. There is also a one more approach. You can use a hash map where it will also have the same time complexity of O of n square. We have used hash map to solve the two sum problem. You can see the very first problem in this LeetCode 150 series. I recommend you to solve this problem using HashMap also. Okay, so guys, that is all about this three sum problem. We'll see you in the next video. I also apologize, there is might be a small background noises in this video. We'll try to reduce in our further videos. Thank you. We'll see you in the next video.